Hello, this is 10.2 regression. The compute the equation of the regression line. So if the value of the correlation coefficient is significant, and then determine the equation of the regression line. The line that is a fit the data best, in other words, that the line of the best fit. The purpose of the regression line is to make it possible to see the trend and then make the predictions on the basis of the data. If the value of the R is not significant, the predictions are the meaningless. The line of the best fit is the line for that the sum of the squares of the vertical distance from each point to the line is a minimum. And the difference between the actual value of the y and the predicted value of the y, we also call the y prime, is a residual of the predicted error. The residuals are used to calculate the line of the best fit. And the line of the best fit is used to predict the value of the y for the specific value of the x. The closer to the point the line the best fit, the better the prediction r when r is a positive. The slope of the line best fit is a positive. When r is a negative, the slope of the line of the best fit is negative. Okay, so this is the the predicted values. And then this is observed the values of the age, okay? And then there is actually the distance between the predicted value and observed values. That's what we call the residual, okay? So the formula for the regression of the y prime is we have this y prime equal to a plus bx, which is like mx plus b. But in order to find the a, we have to use this formulas. In order to find the b is we have to use this formulas, which is similar to the we find the r, okay? So proceed of the finding a regression line equation. So step 1, we make a table that we just did it on the last sections. And then step 2 is to find the values of the table for the each data point and to find the sum of the each column. So we are using the sum of each, okay? And then step 3, when r is a significant, and substitute in the formula to find the value of a and b to find the regression line. So y prime equal to a plus bx. Alrighty, so I already put that in for you for the same problem we did in the 10.1 about the absence and the final grades, okay? So we already got those information. So step 3 was we found the R, right, using a formula. And then the A, so alpha equal to 0.05 and degree of is 5. And then the critical value was plus minus 0.754. So, but negative was 0.944, less than that. So we have to say it's a significant, right? So we can find the a from here. So a is, the formula was sigma y times by sigma x squared. Subtract of sigma x times sigma xy and divide by n times sigma x squared. Subtract sigma x squared. So plug it in. 511 times by 579 minus 57 times 3,745 over n is 7 times 579 subtract 57 squared, which equal to 102.493, which is a. And then b is now another formula, so n times sigma xy subtract the sigma x times sigma y over n times sigma x squared subtract the sigma x squared. And then when you plug it in, 7 times of 3,745 subtract 57 times 511 over 7 times 579 subtract the 57 squared. And then I get negative 3.622. So y prime is a plus bx. So now y prime is a is the sum is 102.493 plus, which is a negative, sorry, because b is a negative, right? So negative of 3.622x. Okay, so that's a formula. So linear regression, which is called a negative directions. All right, next page. Guidelines for the making predictions. So number 1, points of the scatter plot fit the linear regression in linear reasonably well. The value of the R is significant, the value of the specific x is not much beyond the observed value, x value in the original data. And then if the R is not a significant, then the best predicted value for the specific x value is a mean of the y value in the original data. So assumptions for the valid prediction in regression. So number one, sample is a random sample. And for any specific value of the independent value of x, the value of the dependent value of y must be normally distributed about the regression line. The standard deviation of the dependent variable must be the same for each value of the independent variable. So the figure illustrating the assumption of the prediction. So they just kind of show you as what's happening as a dependent variable y normally distributed, and then they're using as an x as a value of the here to see what it is, and then they try to get the best fit the line that they can fit it in for each of the points. Okay. Alrighty, so example 2. So forest fires and acres burn. So the number of the fires and the number of the acres burned are as follows. So fires are x 72, fires 69, up to 45. Acres of y is a 62, 42, 19, 26, 51, 15, 30, and 15. Is the number of the fire related to the acres burned? Okay, draw the scatter plot. Find the correlation coefficient. Determine that it's significant when alpha equal to 0.05. And if the significant, find the y prime. And predict the number of the acres burned when x equal to 60 fire occur. Okay, so first of all, on the plane, this is about the fires, number of the fires, and this is acres burned. So the 72 fires, okay. 72 fires has a 62 acres. 72 about here. So 62 is about here. And then 69, very close to 70, right? And then 42, so right here. And 58, it's about here. And about 19, which is a little bit above the 18, okay? And then 47 fires. 47 is about here. And then 26 is about here. And then the 84, which is very close to 85, 51, so 51, 80, about here. And then the 62 fires has a 15, which is below the here. And then 57, which is about here. 30, about here. And then 45 is actually the 15, so about here. So yeah, so let's see. This is the significant one, okay? All right, so now we're gonna make a fill the table, okay? So for x, 9, 58, because we need to find the r. Okay? 2, 57, and 45. Sum is 494. As a y, 62, 42, 19, 26, 51, 15, 30, and 15. Then sum come out to 260. And multiply x and y, you got 4,464, 2,898, 1,102, 1,222, 4,284, 930, 1,710, 675, and then 17,285. And the x squared becomes 5,184, 4,761, 3,364, 2,000, and 7,056, 3,844, 3,249, and 2,025, where the sum is 31,692. Y squared 3,844, 1,764, 361, 676, 2,601, 225, and 900, 225, and then 10,596. And then we can find the R, okay? So let's get the R here. So we want to go with the R. it in. So n is 8. Sigma xy is 17,285. Subtract. Sigma sub x is 494 times by sigma sub y 260 over 40 n is 8 times sigma sub x squared 31,692 subtract sigma sub x whole square 494 square. Bracket close, open, and n times, and then sigma y square 105 96 subtract and sigma sub y square, which is 260 square, and then bracket close, and then we'll get 0.771. So the R is 0.771, so I think it's a critical, yeah, it's a very the significant. Okay, so now we can find the A. So in order to find the A, that is sigma y sigma x squared minus sigma x and y y n times sigma sigma x squared. Okay, so I plug it in. I get 260 times by 31,692 subtract of 494 times by 17,285 over 8 times of 31,692 subtract 494 square, and then I'm getting negative 31.46. And then the B is n of sigma xy minus sigma x times by sigma y over n times sigma x squared subtract sigma x squared, and plug it in. 8 times of 17,285 subtract 494 times 260 of over 8 times 31,692 subtract 494 square, which is common as 1.036. So y prime is a plus bx, and y prime is plus 1.036x. Okay, and then another question is we need to predict when x equal to 60. So y prime is negative 31.46 plus 1.036 times by 60. I got 30.7. So our prediction is, the prediction is that for 60 fires, 37 acres will be burned. All right, let's look at the next page. Okay, so the marginal change is the magnitude of the change in one variable when the other variable changes exactly 1 unit is the marginal change. The value of the slope of the regression line equation represents the marginal change. So extrapolation, so making a prediction beyond the bounds of the data is extrapolation. So be cautious. When the predictions are made, they are made based on the present conditions on the premises on that the present tense will continue. So assumption may not be accurate. Okay? All right. So that's for the 10.2. Also, this is the end of the teaching you for the statistic 12. Okay, so thank you for listening.